Okay, welcome back. We gave you a break. You worked on the question. We'll come and look at it. Right. It's just an opportunity for you at least to be able to work on the shorter one. And then we'll continue. And then I'll be telling you the sections that we'll be doing. We'll be doing it in parts. The one where we are finalizing that is part 1. And then we'll be going back to part 2. Now, let's see now. Talk to me now. Talk to me. Do you see sides or any angles equal there? That's what we'll be looking for. What sides are equal, what angles are equal. In other words, we're working at the properties now. We're working at the properties so that we can see. Remember, we are looking for 3 elements, 3 elements. We're looking for 3 elements. Let's start. Let's see how you dealt with them. Right? Can we all agree this is 90 degrees? That is 90 degrees. What does that mean? It means you've got a hypotenuse, right? And then you've got a hypotenuse equal, right? Already your 90 degrees angle. Therefore, with that it suffices. With those 2 things, it suffices. Opposite hypotenuse, remember what's hypotenuse? A side opposite 90 degrees. That's very, very important. A side opposite 90 degrees. So it's hypotenuse because there's a 90 degrees. Therefore, if you've got a 90 degrees and a side equal, then that is congruent. And this is how we indicate mathematically the symbol that indicates 90 degrees. Right. Let's go further now. Let's go to number 2. Number 2, you've got 90 degrees. And which side is the hypotenuse? This side. Which side is the hypotenuse? This side. Do you know anything about those sides? No idea. What do you know? You know this side, which is not a hypotenuse, equals to this side, and this side, which is not hypotenuse, equals to that side. So in other words, if you don't know anything about hypotenuse, we cannot say they are congruent. That's very, very important. Now let's go to this one. What do we have here? We have 90 degrees. What else do we have? We have got one side equal. Therefore, hypotenuse and the length of one side equal, then we can say they are congruent. Right, let's look at this one. What are we having? 90 degrees, and what does 90 degrees imply? It implies we have an hypotenuse. Are the hypotenuse equal? Yes. What else do we have? Do we have sides equal? Yes. Therefore, they are congruent. 3 elements, 90 degrees, hypotenuse, and length. 3 sides, angles and side. That's what you'll be looking for. Angles and side. Those 3 properties that we spoke about. Remember, we said we're looking for 3 sides. We're looking for side included angle. We're looking for angle and included side and angle. We look for angle, side. We look for hypotenuse and a side. Those 3, you are always looking for those to say whether a figure is congruent. Same thing. Let's continue here. Have you got 90 degrees? Yes. Have you got any sides equal? Yes. Therefore, hypotenuse and a side, meaning those 2 are congruent. So here, you can do it in many ways again. There's a common side equal. There is another side equal. their angles equal. That's how one can see it. Somebody can say there's 90 degrees, therefore hypotenuse is there and a side is there. Many ways, in whichever way you see it, we see things differently. You're always looking for equal things. You're looking for properties to prove something. 3 of them. Again here we can see if that is 90, this is 90. Therefore that should be a rectangle. But like I say, it's up to you how you see it. We've got 90 degrees. Therefore we've got hypotenuse, which is common. Right? Opposite sides of a rectangle equal. Or you can say again, that's why we say we see differently. Because it's a rectangle, alternating angles equal. The 90 degrees angles equal. The hypotenuse equal. Or this side equal to that side. This angle equals to that one. Hypotenuse is common, a side. So we can see it in different ways. We don't have a specific way of seeing it. As long as we look for these 3 elements, what do we have there which is called, what is equal? That's how you would be proving your congruency. And then lastly, what is the situation there? You've got a 90, you've got a hypotenuse, but you don't know much about the hypotenuse. Have you got a 90? Yes. Have you got a length? Yes. Right? Hypotenuse and a length equal, therefore that is also congruent. Remember, that is a sign that we use mathematically to prove, to say a triangle is congruent to another triangle. Same shape, which is a triangle. Same size. Almost everything equal. Equal in all respects. Remember that. Equal in all respects. Remember that. By doing that, we have to follow and prove certain properties. We have to prove certain properties. Right? A rectangle, exactly the same as a rectangle. Everything is equal. You just have to prove angles equal, sides equal. So it's equal in all respect, one same shape and same size. That is a congruency that we are working on now. We will go to similarity a bit later. Right. Now, we're getting further into congruency now. Triangle ABC. We look at triangle ABC as compared to triangle EDF. We are going to check, is it congruent? But we have to prove why we say it's congruent. We have to look for those sides. We have to look for those sides, those angles. Right? Let's look at this one now. Let's look at this one. Let's look at this one. Let's try and solve this one and see whether it's congruent. Right, let's look at it and see its congruency. There you are. The first one, we want to see triangle ABC. triangle ABC, is it congruent to DEF? All right, we start now. What do we have? 90 degrees. What do you also have? Is the hypotenuse equal? No. Hypotenuse is not equal. Not equal. Not equal. Therefore, already it tells you it's not congruent. Right. That's the first one. Let's go to the second one. What are we given here? We are given this side equals to this side. We are given this side. Okay, let me use different colors. This side equals to this one. What are we also given? We are given this side equals to this one. Now let's analyze. Side, and a side. Therefore, there are three sides equal. Side, side, side. Therefore, triangle UWB is congruent to triangle. Let's follow it like it is there. Triangle, you said U, ne? U is between this one, okay. X, because it's between these two. X, and then V next to the green side, which is Y, and then, of course, the last one, Z. That order is very important. Corresponding sides and corresponding angles is very, very important when you deal with this kind of questions. Right? Let's see this one. What are we having there? What are we giving here? And normally mathematics, like most of the subjects, you work with things that are in front of you. You are given. It's important to read. You get all the information that you have in front of you. Right? Now let's check this one. We can see this angle equals to this angle. Right? Oh, sorry. Right, that angle is equals to that angle. We can also see that this side is equals to that side. Right? So it's an angle, side. Already what we have worked is angle, side, and a side. So angle, side, and a side. But like I said, you can do it as long as you see these three properties equal to each other, then you are on the right track. Therefore, we can say they are congruent. They are congruent. Let's see. PQR. Remember the corresponding P, in this particular case, is angle S. And then let's see where is Q. S, and then green side and angle. And then angle ST, side angle T, and angle R. So that order is very, very important. That corresponding order, you'll see it later, especially with similarity when it comes to similarity. Right? What about this one? What about this one? What about that one? Okay. I'm trying to reduce your distraction there by hiding other questions so that we can focus on what we are working on. Right. There you are. What do you have? I see an angle. I see an angle. What else do you have? I see a side. It's given. A side. What else do you have? I see an angle and an angle. Right. Therefore, it's angle, side, angle. That's what you have. Angle, side, and of course, angle. And that is not the only way. Because you can also say side and a side, angle and a side. That's another way of looking at it. This side equals to that side. Right? Oh, sorry, this one. This side equals to that side. This angle equals to that angle. This side equals to that side. So you can also say angle, side, angle. It depends what you see. And remember, we see things differently. Remember that. It should not always be the same kind of thing. It should not be the same kind of thing. Now, let me give you an opportunity to work at question 5 to 8, and then after that, we'll be looking into our part 2. Let me give you the opportunity to leave question 5 to 8 yourself, so that you can see what we've did with you. Or should I put it here? Let me just put it on a PowerPoint. Let me, part 3. Yeah, after here we'll be going to part 3. Now look at question 5 to 8. Look at question 5 to 8 yourself. We did together question 1, 2, 3, 4. Then you do 5 to 8. After that we'll be going to part 3. Thank you.